All right, so now we're going to find rates of change from the graphs of nonlinear functions. Nonlinear functions are functions that do not have a constant rate of change. Therefore, their graphs are not straight lines. Their slope is not constant if the function isn't linear. We can find the average rate of change between any 2 points by finding the slope of the line connecting the 2 points. All right, so we are finding the average rate of change. So it's not the slope of the line, because you notice, you see, this function here is curving, but we're finding the slope of the line that connects 2 points on the function. All right, so average rate of change with respect to x over AB is equal to the slope of a secant line. All right, so a secant line, put this in your notes. A secant line is a line that connects 2 points on a curve. Right? So we're finding the slope of a secant line when it's nonlinear. So average rate of change is the slope of the secant line for nonlinear. And I'll leave that up for a second so you can write that down.
You got a water, gallon.
You want to sit closer? Huh? You want to sit closer? So the class is just taking notes while you at home are watching this.
What's that first word?
Which one?
Secant.
Secant.
I thought it said scram.
Secant. Does my E look not good? Class is complaining about the E. There we go. That look better?
Hello, class.
You realize if there's any company, she'll take it out of it. At least keep it.
Everyone got this written down? Everybody good? All right, so the average rate of change between any 2 points on the graph of f is the slope of a line through those points. And we already wrote down slope of the secant line. All right. Is this in your notes as well?
No.
Write this down in your notes. You'll find this a lot on the formula on AZ Merit, as well as other things in other math classes. So f of x2 is just the value of the function at a point. And then f of x1 is the value of the function at another point. I shouldn't say a point, for a given x. For a given x value. So the value of the function for a given x value, value of the function at a different x value. That's a better way to say that. Right? And so our two x values, x2 is just one value of x, and x1 is the other value of x. So just put this in your notes, all right, so that you have that information. And when you see it written in function notation, because we don't always write change in y, sometimes it's listed in terms of function notation, then it'll be clear. Recording. So when this is not in the live class, I just keep on going and I let you guys pause at home. But when it's in a live class, I need to let you guys write it down. So those watching have time to write it down as well without hitting the pause button, because I have to wait for all these people. Yeah, all those people.
Can you put right there? Your marker?
Yeah, might be in the whiteboard practice.
Oh.
Everyone got it?
Yeah. My booty.
All right, so let's look at a problem. This one is not in the notes, right? No, this one's not in the notes. So find the rate of change from the graph of a nonlinear function. All right, so here we're looking at the rate of change from f of x from 0 to 1. All right, so we're literally finding the slope of this secant line here, this black line. Here, I can make it green now. That green line. All right, so it's approximating the slope of the function itself. It's not exactly the slope of the function. However, it is the slope of the secant line, the line that connects those 2 points, and it gives us the average rate of change of the function between those 2 points. So this is y equals x squared. All right, so when x is 0, y is going to be 0 as well. The value of the function is 0, so that's 0, 0. And when x is 1, y is going to be 1. So this point here is 1, 1. All right, and then over here, when x is 2, y is 4. So 2, 4 is that point there. So to find the average rate of change from 0 to 1, right? So we're going to take the difference in the y value, so 1 minus 0, over the difference in the x values, again 1 minus 0. So we have a slope of 1, average rate of change of 1. If we find the average rate of change of our function from 1 to 2, right, our average rate of change, we're using the points 2, 4, and 1, 1. So it's going to be the change in y, 4 minus 1, over the change in x, 2 minus 1. So that's going to be 3 over 1, or 3. So you can see that we do not have a consistent rate of slope. And this is clearly not a linear function. Let's continue on and just look at some more functions. And we're going to look at a variety of functions here. This one's in your notes. So notice here we can have the have our average rate of change go right through the middle of the function. That's okay. All right, it's just the rate of change between those 2 points. It's not going to go around the curve. It's just the straight line average rate of change between the 2 points on the curve. All right, so our average rate of change here is going to be the change in the x values, change in the function divided by the change in the x values. All right, so that's going to be 4 minus a negative 1 divided by negative 3 minus 2. So that's going to give us, that's going to be 4 plus 1, so that's going to be 5. And then negative 3 minus 2 is going to be negative 5. So we have a slope here of negative 1. We'll always give our average rate of change as a simplified fraction. It'll be an integer, though, if it happens to reduce that way. But otherwise, it'll just be a simplified fraction. Any questions on this one? And often that line won't be drawn for you, just the points will be, but you'll have to know that you're finding the slope of the line that connects those 2 points. That gives us the average rate of change over the whole interval. So different rates of change at different parts between that interval. Sometimes the slope was 0, down there. Sometimes the slope was very steep, like here. And sometimes it was a little bit less steep. But the average, and sometimes it was negative and sometimes it was positive. But the average rate of change is what's given by the slope of that secant line. Everybody got this one? All right, let's look at this one. So sometimes a single function can be increasing on some intervals, decreasing on others, and constant on others. So this is the first time we've seen this kind of function. This is called, write this in your notes, a piecewise function. A piecewise function has different rules. So it's a function with different rules for different parts of its domain. All right, so let's write the equation for this piecewise function. So notice it starts here at -2, and then there's a change here, right at this point here. I should probably write in blue. I'm writing in green. There's a change right here at that point. So that point there is 3, 6. 3, 6, the function changes. But from -1, -2 to 3, 6, it's the same function. Right? So if we take a look at that function, see we do have a linear function here. We can find the slope of that function. So the average rate of change, I'll write over here. The average rate of change from 3 to 6. Right? So this is going to be from those 2 points there. From 3, 6 to -1, -2. And so I'll just put average rate of change on 3, -1. All right, so that just means from where x is 3. So this is where x is 3, and this is where x is -1. All right, so that's going to be 6 minus a -2. And then 3 minus a -1. So that's going to be 8 divided by 4, or 2. So that section there has a slope of 2. We can write the equation of that. And actually, you can see the y-intercept really clearly, right? It goes right through 0, 0. So the first part of this function here, so here's our equation for our function. So the first part is 2x, and we're going to use that rule when x is between -2 and it's equal to or greater than -2, excuse me, -1. Sorry, I need to look at the x values. -1 to +3. All right, so whenever x is between -1 and +3, the rule is going to be f of x equals 2x. We have a linear function for the next portion. All right, so from 3, 6 to 6, 6, right, we have just not a linear function, but a horizontal line. It's linear, but it's not even just linear, it's horizontal. It's a constant function. So right here, this is constant. So our average rate of change on 3, 6, and actually, I should have written this from least to greatest. Just change that in your notes. I should have written in -1, 3. Kind of just looked at it backwards. That's just going to equal 0. So the rule for that portion of the function, no matter what x is on that small interval there, y is just 6. So it's going to be 6 if x is greater than 3, but less than or equal to 6. The last portion, average rate of change, occurs from 6, 6 to 10, 4. So the average rate of change on 6, 10 would be 4 minus 6, so change in the y values, divided by change in the x values, 10 minus 6. So that's going to be negative 2 divided by 4, or negative 1/2. It's a little harder to write the equation of that piece because we don't see it going through the y-axis. But what we could do is use point slope to write the equation. So let's use point slope. All right, so for that portion, it would just be y minus, and so we'll use 10, 4. Y minus 4 equals negative 1/2 x minus 10. Y minus 4 equals, we'll distribute, negative 1/2 x. That's going to be plus 5. And if we add 4 to both sides, y equals negative 1/2 x plus 9 is the last piece here. So the rule we're going to use for our function when x is between 6 and 10 is going to be negative 1/2 x plus 9. And that's if x is greater than 6 but less than or equal to 10. I'm going to put this over here. So our function is doing all kinds of different things. Do I have room over there? Maybe over here. I need this space. There we go. Sorry. There you go. So our function is increasing from negative 1 on the interval negative 1 to 3. Our function is constant on the interval 3 to 6. And our function is decreasing on the interval 6 to 10. So this one problem had a lot to it. We learned a little bit about piecewise functions, a little bit about writing the rules for piecewise function. We have to change, we list the rule and which parts of the domain that we use that rule on. And then a little bit about average rate of change. So, and a review of increasing, constant, and decreasing. Is that the last problem on this page? Oh, we have the two. They skipped. Yeah, that one took up a lot of space. So. Next couple problems are a little quicker.
What am I doing? I might go open the X monitor to right.
So I'm going to give you one more minute to. Okay. Okay. All right, so let's look at a few more finding average rates of change from nonlinear functions. Here we have a square root function. We can easily identify the points. So I didn't even write in the equation here, but the equation is y equals the square root of x. So in your notes you can write down that equation. All through the middle of the board I get this little glitch. All right, so the average rate of change from 0 to 1, so 0 is at 0, 0. 1 here is 1, 1. So our average rate of change is going to be the change in the y coordinates, right? Change in the value of the function over the change in x. So that's going to be 1 minus 0 over 1 minus 0. Which is 1 over 1 or 1. Right? So we have a slope of 1 for the secant line connecting those 2 points. 4 is 4, 2. The slope connecting x equals 1 to x equals 4 is going to be 2 minus 1 over 4 minus 1. Right? So difference in y values over the difference in x values. So that's connecting those 2. Right? So that would be 1/3. Right, so you can see nonlinear, our slope changes. Everybody got this one down? Hope we can at least finish this the page of notes. It's on the next page. Not too much farther. Got it? All right, so here we have a log function, all right? And we should also review plugging into it. So we can kind of see them on the graph, but I think it's very worthwhile for us to practice plugging in and evaluating log functions. All right, so to find, so x equals 2, f of 2 is going to be log 2 of 2, right? So in other words, what's the exponent we have to raise 2 to get 2, class? So what's log base 2 of 2 equal to? 1. How about log base 2 of 8? What does that equal? No, not 4. 3.
Oh, 2.
3, because 2 cubed,
Yeah.
2 cubed is 8, right? And 2 to the first is 2. All right, so our y values, our points here, we're at 8, 3, and 2, 1. So the average rate of change is going to be 3 minus 1 divided by 8 minus 2, which is going to be 2 over 6, or 1/3.
That's not the point. That's 2, 4, 6, 8. Ours is 10, 20, 30.
Oh, is that a different function?
Oh, it's on the next page.
Oh, it's on the next page. It's on the back.
Told you it was in there.
All right, so average rate of change. So log base 2 of 1/2. What would I have to raise 2 to get 1/2? -1. Right, 2 to the -1 is 1/2. And then log base 2 of 4 would equal? What was it? 2. Yep. Because 2 squared is 4. All right, so our points here are going to be 1/2, -1, and 2, 4. So the average rate of change is going to be 4 minus a -1 divided by 2 minus 1/2, which is 4 minus a -1, that's 4 plus 1, that's 5. 2 minus 1/2, well 2 is the same as 4 halves. So 4 halves minus 1/2 is 3 halves. So that gives us 5 divided by 3 halves, but don't leave it like that. That's the same as 5 times the reciprocal, 2/3. So our answer for our slope here is 10/3. So it was a little tricky thing with the simplifying. What's that?
You have a 2, 4 when it's 4, 2.
Oh, sorry. Oh, did I plug it in wrong too?
No, I don't know. Actually, I don't know about that. But
Yes, I did. Oops. Well, ignore that. I wrote it backwards. Woo, don't write that down.
I seen it.
Sorry. Thank you, Cisco. This is 4, 2. I wrote down 2, 4 by mistake. Just try to switch the variables. All right, so that's going to be 2 minus a -1 divided by 4 minus 1/2. So that's going to be 3 in the numerator. And 4 is the same as 8 halves. So that's going to be 3 divided by 7 halves. But again, don't leave it like that. That's 3 times 2 sevenths, or 6 sevenths. That's our slope. Thank you. Didn't even see I wrote them backwards.
You say something stupid again on you.
Yeah.
What happens?
All right, so I think I'm going to end the podcast. So I'm going to run out of time, but there'll be another podcast. So bye for now.